Most massive black hole collision ever detected by LIGO, a groundbreaking discovery. Imagine a cosmic collision so powerful it warped the fabric of spacetime itself. Astronomers have just detected the most massive black hole merger ever recorded, challenging everything we thought we knew about these cosmic monsters. Welcome to GW231123, a gravitational wave event that's rewriting the rules of black hole physics. Sign up for CNN's Wonder Theory newsletter to dive deeper into the universe's biggest mysteries. The discovery, made possible by the Laser Interferometer Gravitational Wave Observatory, LIGO, reveals two black holes, each over 100 times the mass of our Sun, slamming into each other in a merger 12 billion light-years away. But here's where it gets controversial: these black holes shouldn't exist according to our current theories. Gravitational waves, predicted by Einstein in 1915, are like cosmic earthquakes. LIGO first caught them in 2016, earning scientists a Nobel Prize for proving Einstein right, again. Since then, over 300 black hole mergers have been detected, but GW231123 is a game-changer. These detectors are the most sensitive instruments humanity has ever built, explains Mark Hannum, a LIGO scientist. We're witnessing the universe's most violent events through the tiniest vibrations. But what makes GW231123 special? The black holes fall into a mysterious mass gap, a range where stars can't produce black holes through normal collapse. This merger is a puzzle, says Charlie Hoy, a researcher at the University of Portsmouth. The black holes are not only too massive but also spinning near the speed of light. It's like seeing a cosmic dance that defies our models. So, how did they form? One theory: successive mergers. If black holes collide repeatedly, they could grow to forbidden sizes. This isn't just a one-off event, it hints at a hidden population of superblack holes born from collisions, not star deaths, says Dan Wilkins of Stanford. But not everyone agrees. Imre Bartis at the University of Florida suggests they might form in dense star clusters or from massive star collapses. The spin, however, is a clue: only previously merged black holes would spin this fast. Gravitational waves are uncovering a secret black hole society, says Hannum. These aren't the black holes we see gobbling stars, they're the ones growing by eating each other. The implications are staggering. Future detectors like the Einstein Telescope could uncover even more giants, revealing whether GW231123 is a freak event or the tip of an iceberg. As Zoltan Hyman warns, this merger is either a cosmic outlier or a doorway to a new universe of black hole physics. Your turn. Do you think most massive black holes are born from star deaths or cosmic collisions? Share your theories in the comments. Correction: an earlier version incorrectly stated Charlie Hoy's affiliation. Monster black hole merger, 240 suns in size. Imagine the sheer power of two cosmic behemoths smashing together with enough force to warp the very fabric of reality. That's exactly what a global team of scientists has just confirmed with the most massive black hole merger ever spotted. This groundbreaking find isn't just a win for astronomy, it's a wake-up call that could reshape everything we thought we knew about the universe's hidden giants. And this is the part most people miss: while black holes often steal the show in sci-fi, this real-world event is pushing the boundaries of what's possible, challenging our deepest theories in ways that might just spark a scientific revolution. Let's break this down step by step, especially if you're new to this cosmic stuff. Black holes are like the ultimate traps in space, regions so dense that not even light can break free. Think of them as cosmic vacuum cleaners, pulling in everything nearby with an unstoppable gravitational grip. This happens because of something called the event horizon, which is basically the point of no return.*Once you're past it, there's no escaping. For example, the supermassive black hole at the heart of our Milky Way galaxy, known as Sagittarius A*, is about 4.3 million times the mass of our Sun, making it a prime example of how these entities can dominate entire galaxies. They're not just destructive, they're also puzzles that keep astronomers up at night. As we can't directly observe them, we rely on the effects they have on surrounding space and light. Now, on to the star of the show, this massive merger. Detected on November 23, 2023, and labeled as event GW231123, it was picked up by a network of high-tech detectors called LIGO. These instruments, spread across the United States, Italy, and Japan, are designed to sense the faintest ripples in spacetime, known as gravitational waves. Gravitational waves are like echoes from the universe's biggest events. Imagine dropping a boulder into a still pond and watching the waves spread out. Albert Einstein first predicted them back in 1916 as part of his theory of general relativity, and they've been key to unlocking mysteries ever since. In this case, the collision involved two enormous black holes, one about 100 times the mass of our Sun and the other around 140 times. When they merged, they created a single black hole equivalent to 240 suns in mass. That's huge. To put it in perspective, it's like combining the weight of 240 stars like ours into one point in space. But here's where it gets controversial. This merger is so massive that it defies the standard models we use to explain how black holes form. Traditionally, scientists believe black holes come from the collapse of massive stars at the end of their lives, but events this big shouldn't happen according to those rules. Some researchers are even suggesting that these black holes might have resulted from earlier mergers of smaller ones, which could mean there's a whole chain of cosmic collisions out there that we're only just starting to understand. It's a counterpoint that's stirring up debate. Could our models be missing something fundamental, or is there a new process at play in the universe's evolution? This discovery has physicists scratching their heads and rethinking their approaches, as Mark Hannum from Cardiff University put it in a statement. Black hole mergers this massive are forbidden through standard stellar evolution models. It's a real head-scratcher that could lead to major revisions in how we map out the cosmos. This isn't the first time gravitational waves have made headlines. The LIGO Observatory, funded by the National Science Foundation, kicked off the modern era of this research back in 2015 when it first detected these waves from a black hole merger. Since then, collaborations with Virgo in Italy and Kagra in Japan have helped identify over 300 such events, giving us a clearer picture of what's happening in distant parts of the universe, including our own Milky Way. Amit Singh Ubhai, a research fellow at the University of Birmingham and part of the team, described this find as a landmark achievement in gravitational wave science, emphasizing how it pushes us to innovate and build better detectors for the future. Looking ahead, there's still a lot of work to do. Gregorio Carullo, a professor at Birmingham who analyzed the data, noted that unraveling the full story of this merger could take years, as the signal is incredibly complex. It's an exciting time, with potential breakthroughs that might reveal more about the universe's origins and evolution. But not everything is set in stone. For instance, while some experts are excited about the implications for stellar evolution, others might argue that this could point to unknown physics beyond our current understanding. And this is the part most people miss. Discoveries like this don't just add data points, they challenge our assumptions and open doors to entirely new questions. So, what do you think? Does this massive merger make you question how black holes fit into the bigger picture of the universe, or do you have a different take on what it means for our cosmic models? Jump into the comments and share your thoughts. Whether you're agreeing with the scientists or playing devil's advocate, I'd love to hear your perspective. Scientists found a black hole that shouldn't exist. Now physics has a problem. Imagine discovering a black hole so massive that it defies everything we thought we knew about the universe. That's exactly what scientists have stumbled upon, and it's sending shockwaves through the physics community. But here's where it gets controversial. This black hole shouldn't exist according to our current understanding of stellar evolution, so, what does this mean for our theories? Let's dive in. Over the past decade, the LIGO LVK network has been on a roll, detecting hundreds of black hole mergers. Yet, none have been as jaw-dropping as GW231123. This behemoth, weighing in at 225 solar masses, dwarfs the previous record holder, GW190521, which was only 140 solar masses. And this is the part most people miss. The black holes involved in this merger are so large that they challenge our fundamental understanding of how stars live and die. To put this into perspective, the Laser Interferometer Gravitational Wave Observatory, LIGO, first made headlines in 2015 when it confirmed the detection of gravitational waves, ripples in spacetime caused by cataclysmic events like black hole mergers, supernovae, and neutron star collisions. That initial detection was from a black hole merger that created a new black hole 62 times the mass of our Sun. Since then, the LVK network has continued to push boundaries, detecting the first neutron star merger in 2017 and the largest black hole merger, 140 solar masses, in 2021. Now, a preprint uploaded to the AR-14 server reveals a new heavyweight champion, GW231123, a black hole born from a merger that produced a staggering 225 solar mass object. Discovered on November 23, 2023, during the fourth observing run of the LVK network, this black hole is too big to fit into our current models of physics. Here's the kicker: according to standard stellar evolution theories, black holes this massive simply shouldn't exist. Mark Hannum, a member of the LVK collaboration from Cardiff University, summed it up in a press statement: "This is the most massive black hole binary we've observed through gravitational waves, and it presents a real challenge to our understanding of black hole formation." Black holes this massive are forbidden through standard stellar evolution models. To form GW231123, its two predecessor black holes likely weighed around 100 and 140 solar masses, respectively. This places them in the upper mass gap, a range where black holes aren't expected to form directly from stars. The supernovae of such massive stars should leave behind no stellar remnant at all. So, how did these black holes form? One theory is that they resulted from earlier mergers of smaller black holes, but this raises more questions than answers, ***. And it's not just their size that's puzzling. Both black holes were spinning at 80 to 90% of their maximum speed limit, making them the fastest spinning black holes ever recorded by LVK. Charlie Hoy, another LVK member from the University of Portsmouth, noted, "The black holes appear to be spinning very rapidly, near the limit allowed by Einstein's theory of general relativity." This makes the signal difficult to model and interpret, but it's a fantastic opportunity to refine our theoretical tools. Detecting a black hole more than double the size LIGO is typically sensitive to, around 100 solar masses, pushed the observatory to its limits. According to Science News, the LVK network only detected a tiny blip from this merger, just 0.1 seconds at the tail end of the collision. Nearly a decade after its first detection, LIGO's mission to uncover gravitational waves continues to revolutionize our understanding of the universe. But GW231123 isn't just another discovery, it's a call to reevaluate our most cherished theories. Do we need to rewrite the rules of stellar evolution? Or is there something fundamental about black hole formation we're missing? What do you think? Let's keep the conversation going in the comments. This is one cosmic mystery that's far from solved.